Greeting Python fuzzy logic fans and oil field enthusiasts. Today, we are uncovering the practical side of Scikit-Fuzzy in Python, exploring how to craft a simple fuzzy logic system for candidate pair selection for hydraulic fracturing. No fancy words, just a simple journey to the tools and techniques that make decision-making in its dynamic field straightforward and effective. I'm using Google Colab in this tutorial. Google Colab, short for Collaboratory, is a cloud-based platform provided by Google that allows users to write and execute Python code in a collaborative environment. It offers free access to GPU resources, making it particularly advantageous for machine learning tasks. So let's get started. The first step is to import libraries. As you can see, I already imported by using this command. I'm importing the Scikit-Fuzzy libraries. And then other libraries include NumPy for numerical operation. We import control command from Scikit-Fuzzy. And also we are importing data visualization libraries, including Matplotlib and also Seaborn. So the second step is to define fuzzy variables. In this part, we will have two categories, input and output. So our input variables are four variables, including permeability, skin, sand phase pressure, and water cut. Okay, so the output variable is the suitability level. Okay, so for each variable, there will be some ranges. As you can see, we are actually introducing this input variables by using this control antecedent component, which is a very important component in rule-based system and fuzzy logic. It helps defining the rules and conditions for making predictions or decisions. So as you can see, the range starts with the minimum range, the minimum and also the maximum, including some increments. Okay, so these increments, which is for this case, we have 0.1 millidarcy to 21 millidarcy, with the increment of 0.001. This actually lowering this increment allows precise modeling of subtle variations. So this extended range ensures comprehensive coverage and mitigate edge effects. So it's recommended if you are going to have a permeability range from 0.1 to 20, for example. You increase this to 21 in order to actually mitigate this edge effects. This provide a robust representation of values for effective fuzzy logic analysis in this application. So the second variable is scheme. So as you know, and as I described, we are using control antecedent, NP range. The range of the scheme is from -10 to 10. Okay, so the increment is 0.1. The third variable is the sand phase pressure. Again, we are using the same code, but the range are from 1,000 to 2,000. Okay, so the fourth and the last variable is the water cut. So the water cut starts from 0 to 70%. And then we are moving to our output. Our output is defined by control consequent, which is a class in fuzzy logic control system that represents the output variable for the results of fuzzy inference process. So here in this case, we have a range from 0 to 4. And then also our defuzzify method would be centroid. Okay, we have different defuzzification methods, but in this case, we are going to use centroid. Of course, we can use different defuzzification methods in order to see their effects on our case. Okay, so the next step is to defining the fuzzy sets. Okay, for this case, we are going to have, based on the numbers of the input and output variables, you can define different numbers of fuzzy sets. In this case, we are for the input variables, we are going to define 3 fuzzy sets for the input variables and 4 fuzzy sets for the output variables. Okay, so in this case, actually for our case, in order to define the fuzzy set, we are using this command, which is fuzzy trimmed. The function takes 3 parameters: lower bound, as you can see, this is the lower bound, and the middle, which is the peak value, and also the upper bound. Okay, so this is of course for the triangular function that we are using. So for skin we have low, medium, and high, and also for sun phase pressure we have low, medium, and high. So we need to define our ranges based on the description that I've. So in this case, we are having also the water cut, so which is low, medium, and high. For the low is less than 15%, less than for the medium, less than 35%, and for the high, which will be more than 55%. For the output variable, we are using the same formula. In this case, we are going to include the very good, not a candidate, which is actually getting a negative number, and then for a not bad, which would be 1, and then for a good 2, and for very good, which will be more than 3. So this is the fuzzification output that will be defined in the later stage of our case. So the most important part is defining the rules. So formulating rules that express relationship between input variables and output suitability level. So rules determine how different combination of input influence the output. So adjusting the linguistic terms, rule structure, or adding more rules to cover a broader range of scenarios are some options that you can use in your case. So the current set of rules may not cover all possible scenarios, leading to limitation in the system decision-making capabilities. So as you can see in the first rule is that if the permeability is low, skin is poor, and sun phase is high, and water cut is low, then the suitability is very good. So we are using the same actually formula for other rules. As I said, the rule numbers, actually increasing the rule numbers will increase the efficiency and also the efficiency of the system. But in this case, because this is a simple example, we are going to limit the numbers of the rules. But one explanation is that we can come up with actually because we have four four variables, and for each variable we have 3 sets. So normally in this case we need to have about more than 300 or 324 exactly rules to define actually the output clearly and to avoid the script values. So the next step is to creating control system and simulation. So this code is going to actually aggregate these rules and actually come up with a control system. And also for creating simulation, we need to use this code, the control system simulation with the candidate selection control, which is defined here. And then we can also set input variables and computing output. So executing the simulation to compute the output solubility level based on the set variables and also the defined fuzzy logic rules. So in this case, we are going to set the input values, candidate selection simulation inputs. So we are going to use 2 for the permeability. So for example, in your field, the permeability of the well is 2 and the skin is 4. Sand phase pressure is 1,800 and the water cut is 5%. So this is somehow the input variables that we are including to check the accuracy and output of the well. So of course, in order to see the results of the falsification, we need to compute the output. So we are going to use this code, candidate selection simulation dot compute, in order to compute. And then, of course, we need to be able to print the results. So the result will be printed by this code. And of course, using Matplotlib and also seaboards, we are going to visualize our case. For visualization, we need to set the style for the seaboard and then plot the fuzzy sets for each variable, for permeability, for skin, for sand phase pressure, and also for water cut, and finally plot the results and show the plot. So in this case, in order to see the output, I'm going to run the first, which is pip install Scikit-Fuzzy. I've already actually downloaded this, so it says that the requirements are already satisfied, means this library is already installed. And the next step, I want to run this course, actually code that is already described. I'm going to click here, as you can see, this code will be run, and then let's see what will be the output. Okay, let's go and see. So the output of this actually printing the results here in this case, as you can see, we have print the results. So the first case is we can see the suitability level of our case. In this case, we can see that the suitability is 3. Okay, and then we have the plots, plot for permeability, plot for skin. So these are the plot for different actually variables that we've already used. As you can see, this is the triangle membership function, and then it's included the fuzzy set. And as you can see, we have the low, medium, and high for permeability. Same goes for the skin and sand phase pressure and water cut. And as you can see here, the suitability level is shown to be 3 and included in a very good included to be a very good candidate. Okay, I hope you've enjoyed and you've learned something out of this this tutorial. Of course, if you want to see more details and learn about this kind of analysis, I refer you to my published papers and also online tutorials for using this fuzzy logic for candidate selection for hydraulic fracturing. Of course, this kind of analysis can be adopted for other oil field topics, which needs precise and which of course come up with some uncertainty in their analysis. Thank you very much, and see you in the next video.